The directions for this problem say find all solutions on the interval from 0 to 2 pi. And the problem that we're solving today is 1 minus 2 tan x is equal to the tangent squared, the tangent squared of x. Now, the first thing that I want to do, since I have all tangents, is to move everything over to one side of the equation. So I have 0 is equal to the tangent squared of x. I'm going to add 2 tan x to both sides, so plus 2 tan x. And I'm going to subtract 1 from both sides. So here I have a quadratic in tangent. One method to solve this is to let u equal the tangent of x, which means that tangent squared of x would equal u squared. So if we make the substitution, we're left with 0 is equal to u squared plus 2 times u minus 1. There's no nice way to, no integer way to factor this. So what I'm going to do is use the quadratic formula. So the quadratic formula says negative b plus or minus the square root of b squared minus 4ac all over 2a is what u will be. So u will be equal to 0 when it is equal to this value, if there are any real values. And so if I put a 1 here, this is my a, 2 is my b, and negative 1 is c. So I get a negative 2 plus or minus the square root of 2 squared, so 4, minus 4 times 1 times negative 1, all over 2 times 1. So I get negative 2 plus or minus, so this is 4 times negative 1, so this is 4 plus 4, or 4 minus a minus 4, which is 8 all over 2. So that's what our u is equal to. So we can do a little bit of simplifying here. The square root of 8 can be written as the square root of 2 times the square root of 4. And the square root of 4 is 2, so we can write this as 2 square root 2, or 2 times the square root of 2. So if we can give ourselves some more space, then we know that u is either equal to a negative 2 over 2 plus 2 square root 2 over 2, or u could be equal to negative 2 over 2 minus 2 square root 2 over 2. So when you have more than one term in the numerator, you don't want to forget that that all terms are divided by the 2. So here, 2 divided by 2 is just 1, and 2 divided by 2 is 1. So this simplifies further to negative 1 plus the square root of 2. Or u is equal to, again, we get a negative 1, and here now we have a minus square root 2. So negative 1 minus the square root of 2. Now, the square root of 2 is bigger than the square root of 1, which is 1, but it's less than the square root of 4, so it's less than 4. So we know that the square root of 2 is greater than 1, but less than, less than 2, because the square root of 4 is bigger than the square root of 2. Now, if we added a negative 1, so plus a negative 1, plus a negative 1, plus a negative 1 to each one of these values, we can see that this is going to be 0 is less than or equal to negative 1 plus the square root of 2, and it's going to be less than 1. So now we know that the size of this value right here is between 0 and 1. And we can do the same with negative square root 2. With negative square root 2, we have negative square root 2 is going to be greater than a negative 2, because it's less negative than negative 2, but less than negative 1. And we can, again, add a negative 1 to both sides, so plus negative 1, or to all sides, plus negative 1. And what we have here is negative 3 is less than negative 1 minus the square root of 2, which is less than negative 2. So this value right here is between 0 and 1, and this value right here is between negative 2 and negative 3. A lot of people just plug these things into their calculator and find out the value that way, but I like to evaluate it without a calculator and to show you how that can happen. So we know that this first solution for u is between 0 and 1, and this second solution for u is between negative 3 and negative 2. U is equal to the tangent of x. So we can replace the tangent of x for both u's, and now we have two trig functions to solve for. We have the tangent of x is equal to negative 1 plus the square root of 2, and we have the tangent of x is equal to negative 1 plus the square root of 2. So here we can take the inverse tan of both sides gives us x is equal to the inverse tan or arctan of negative 1 plus the square root of 2 plus pi k. This means that if you add any number, any integer value of pi to this, we'll get another solution to our original equation, making the original equation true. So here we get, if we take the inverse cosine of both sides here, we have x is equal to the inverse tan of negative 1 plus the square root, minus the square root of 2. Minus the square root of 2. And the best way to talk about these solutions, plus 2 pi k, is to draw the tangent function. So if these are my intervals of pi over 2, let me fix this one. This is negative pi over 2, and this is pi over 2. And let's use a different color. The tangent curve comes from negative infinity and travels towards positive infinity, and hits 0 at integer values of pi, and it has an asymptote at odd values of pi over 2. This one needs to be a little bit more. Okay, so if this value right here is somewhere between 0 and 1, we can draw in the line y is equal to, so this is the line y is equal to negative 1 plus the square root of 2. And so the value that this value here, the inverse tan value, it's going to come from the interval between negative pi over 2 and positive pi over 2. And then if you add 1 pi to it, you get this solution. If you subtract 1 pi from it, you get this solution. Okay? So this would be the k equals 0 value. This would be a k equals 1, and this one here is a k equals negative 1. Then we could draw another line where y is equal to -1 minus the square root of 2. And in this case, we get our principal solution, or the inverse tan of -1 minus the square root of 2 is right here. And then the second one, if you add pi, so this is a k equals 1, and this one right here is a k equals 2. This one right here is a k equals -1. Okay, and here is k equals 0. Now, I kind of stopped off this graph a little truncated here. It goes on forever. It continues on and on and on. But the reason why I didn't continue on is because the solution originally wanted values, x values between 0 and 2 pi. So I stopped the curve at 2 pi. And you'll notice that if I can highlight this, 0 to 2 pi. So this first solution for this one here is not included in 0 to 2 pi. So the solutions that we're going to use, the first one we get is this one, when k equals 0. And then we get one from this group when k equals 1. And then we get one from this one when k equals 1. And then the last one comes from this one when k is equal to 2. So we can list the number of solutions. X will have to equal the inverse tan. For this one, it is -1 plus the square root of 2. Okay. For this one, it's, not negative tan, inverse tan. The inverse tan of -1 minus the square root of 2 plus pi. So we had to add a pi to get here. And then this is our third solution, the inverse tan of -1 plus the square root of 2. So we're going to add pi to get to that one. So plus pi. And our final solution is the inverse tan of -1 minus the square root of 2 plus 2 pi. So these are all the solutions for the equation 1 minus 2 tan of x is equal to the tangent squared of x on x an element of 0 to 2 pi. So these are the 4 possible solutions to this equation on this interval. There's an infinite number of solutions, and these would be them right here if our domain was the entire reals. And over here I said plus 2 pi k, and what I meant was plus pi k. All right, that will be the end of this problem. Thanks for watching.